Whereas on the right video we see, in batch mode, the same test on the Lafarge partition system. The applied seismic simulation is of a magnitude 4 on the Richter scale. At this level, the brick wall collapses in pieces, whereas the plasterboard partition remains totally intact. The second trial was conducted with a thicker and stronger partition. More construction elements were added. These include a small perpendicular panel which serves to add support to the main panel. There is also a metallic shelf monoblock loaded by a mass of 40 kg, which simulates the action of kitchen furniture. The applied seismic simulation is of a magnitude 4 on the Richter scale. At this level, the two types of building materials used are sufficiently resistant. We begin the seismic simulation again, this time using a magnitude 5 on the Richter scale. The strengthened brickwork is crushed against the concrete frame at the four corners. The heavy weight shelf falls down. We begin the seismic simulation again, this time using a magnitude 6 on the Richter scale. As you can see, the brick-built wall, in spite of its large thickness and side reinforcement, eventually collapses, whereas the plasterboard partition remains in place. For earthquakes up to 4 on the Richter scale, the brick behaves in highly resistant manner, preventing the whole building from moving. Unfortunately, this gives the building's occupants a false impression of the security of the building. This false impression is dangerous because a major earthquake of up to 6 and more on the Richter scale would collapse the brick-built wall and eventually bring the entire building down as well. In comparison, Lafarge plasterboard solution does not collapse. Furthermore, its lightness and flexibility does not weigh down